Welcome, everyone, to this session entitled Healthcare Case Studies. I have the pleasure and honor to be chair. My name is Anja Maier. I'm Professor of Engineering Systems Design, and I am pleased to also say that this conference has seen a number of healthcare sessions already, kicking it off with a workshop on health systems design on Monday. And today, this is at least the third session. So very nice. And I encourage you all to also look at your colleagues' work and see this as a wider conversation. And also congratulations to the conference organizers. So far, it's been really coherent in the session composition, as well as enough differences to have a very good discussion. So now we have in this session 5 papers, 5 manuscripts that are presented, and it'll unfold as follows. I will introduce the speakers in the way that it was shared with me through ConfTool, and thereafter we will play the respective video presentation, and once we've have the composition of all the 5, we'll open the plenum in further discussions. And please do use the chat along the way so we can begin to look at the questions, and once we are through, we'll open cameras for everyone. Now, let us start with the first paper entitled A Designer's Perspective on Additive Manufactured Smart Wearables for Pediatric Habilitation, presented by Matthew Bonello from the University of Malta and co-author. Now, Matthew is sharing with us that he received a Bachelor in Engineering from the University of Malta and is now working as a research support officer with the Department of Industrial Manufacturing Engineering, also within the University of Malta. So let us hear what Matthew and co-author have to say.
So hello, my name is Matthew Bonello, and on behalf of my co-author, Professor Farrugia, I will be presenting you the study we conducted titled A Designer's Perspective on Additive Manufactured Smart Wearables for Pediatric Habilitation. So, design for additive manufacturing, the FAM, is being considered to enhance development of 3D printed medical devices. Apart from 3D printing aspects, medical device designers have taken account various factors, for instance, the end user requirements, regulations, and standards. And this applies as well for smart wearables for pediatric habilitation, SWEF, which have a multiple of users, including the child who is undergoing habilitation, the occupational therapist, and the child's legal guardian. These users generate various requirements which the designer must abide with to ensure a high-quality user experience. These are the works most related to the study conducted. However, as summarized on the diagram on the right, a research gap was identified. Thus, this paper will address the research question: to what extent do engineering designers require a proactive design support tool to design smart wearable habilitation devices for additive manufacturing, and at which stage of the design process would it deem fit? Going on to the method, semi-structured interviews were conducted with 8 engineering designers to take note of their experience and insights on additive manufacturing, user experience design, and user involvement when developing SWEF. Also, some small-scale quantitative data was collected via ranking questions and Likert scale. Then, following the interviews, thematic analysis was conducted to identify important themes throughout the qualitative data recorded. Now, going on to the identified themes for the study. The initial theme identified was additive manufacturing prospect to fabricate SWEF, which brings about various advantages, including quick manufacturability, customizing the device, and personalizing it according to the specific needs and likings of the child. And although additive manufacturing brings about these advantages, some of the designers pointed out that 3D printing has not yet reached its full potential, that they rarely take into account when designing, and they mostly use additive manufacturing for prototyping only. Meanwhile, designers were asked to rank typical challenges they encounter when designing products for additive manufacturing, with the most problematic challenge being embedding of electronics. With regard to the embedding of the electronics, the most referred mean result it was post-additive manufacturing assembly, followed by remote assembly via multi-purpose 3D printer. The second theme identified is on design of user experience for additive manufactured SWEF. So according to designers, the criteria which generate a high-quality user experience for children when interacting with such devices are ease of use, fun, and attractiveness. During the study, though, it was unclear whether additive manufacturing aspects have direct impact on user-product interaction, but some of the points raised would suggest otherwise are that additive manufacturing might impact comfortability, that poorly designed manufactured parts might frustrate the child, and also the ergonomic aspects such as the size, the fit, and the weight of the device. Also, additive manufacturing can have an indirect impact due to its mass customizability, making therapy execution at the clinic or at home more efficient for both the occupational therapists and the parents. Going on to the third theme identified is on the multiple stakeholders insight on additive manufactured SWEF. Due to its multidisciplinary aspects, it is unlikely for designers to have sufficient knowledge in the field of habilitation to be able to design such devices unassisted. Hence, the designers emphasize the importance of collecting stakeholders' requirements at the initial stage of the design, while having input from the users throughout the design process. In this case, the main stakeholders identified includes designers as well, but it was acknowledged that although designers' input is significant, their requirements should not be prioritized above the user needs. With regards to the process, the 8 designers depicted that in order to design SWEF for additive manufacturing, a structured design process is required. A few key steps discussed include user-centered approach, use of the ICF checklist by the World Health Organization, validating the designs and abiding with the standards and regulations, for instance, the ISO 13485, amongst other aspects. Additionally, the participants highlighted some typical challenges they encountered when designing similar products, which are listed here. Now, going on to the preliminary framework generated, designers interviewed recommended that the framework should be implemented as early as possible in the design process, with the FAM being incorporated between the conceptual and the embodiment stage. Additionally, all of the designers agreed that the framework would be suitable for both novice and experienced designers, with 7 of the designers concluded that they would always refer to such a framework to avoid losing sight of any important parameters. Thus, taking into account this presented data and the previously mentioned themes, a preliminary framework was generated. So the framework presented here takes an iterative co-designing approach with the relevant stakeholders who will be interacting with the device. In the initial stage, a profile of the primary user should be built to design the device according to their specific needs, considering user experience criteria. Also, as previously noted, the DFAM is included between the conceptual and the embodiment to support the development of the device purposely for additive manufacturing, for instance, reducing superfluous material and implementing additive manufacturing rules, in addition to the consideration of the multi-material part printing, embedding of electronics, and surface finish to tackle the additive manufacturing challenges prioritized by the designers. Thus, the resulted framework will provide a reference for engineering designers to optimally develop SWEF for additive manufacturing via the FAM, whilst ensuring a high-quality user experience for the respective users. Thus, although it is important to note that this framework is still in its preliminary stage and it will be supported through future studies with designers and the respective users of such devices. Thank you for your attention, and I'd be glad to answer any questions you may have.
Okay, on behalf of everyone, thank you, Matthew. We will open the conversation after all presentations. Now, the second set of speakers, or the second set of works, is presented by Guillaume Thomann. The paper is called Serious Game Design, Principles for Motor Evaluation of Patients with Neurological Diseases. So that is specifically to a certain condition. Now, Guillaume is assistant professor in the field of mechanics, and he writes that his main research activities are focused on the development of design tools and methods in the medical and in particular in the handicap domains sectors. So let us hear what this paper is focusing on.
Hello, ladies and gentlemen. I'm Guillaume Thomann, Associate Professor at the Alpes Grenoble University, France. I will present today the paper entitled Serious Game Design Principles for Motor Evaluation of Patients with Neuromuscular Disease. This is the agenda of my presentation. First of all, I will present some design principles for a serious game development, then the context of this development, the work we developed, and conclusions and discussions. Today, video games are widely used for medical training and practices, as well as for surveillance, pain management, rehabilitation. The use of games has the advantage of creating a fun and interactive environment. It stimulates patients, promoting recreation, motor development, reasoning ability, the motivation to overcome patient limitations, etc. Games are computer applications based on computer graphics and designed for entertainment. According to Lamarty and Salik, serious games can be defined as an application of three components: entertainment, multimedia, and experience. Game design methods are based on knowledge of gameplay. It is the set of mechanisms used to increase player enjoyment and satisfaction. 5 important characteristics can be considered for the design of serious game: scope, activity, modality, style of interaction, and environment. We have the objective to define and to develop serious game for the MFM assessment scale. The motor rating scales are instruments that quantify the capabilities of patients for functional activities. This is a case of the MFM. It is a validated procedure composed of 32 items grouped into 3 areas: standing and transfer, axial and proximal motor function, and distal motor function. This figure shows in 3 colors the 3 domains detailed before. An MFM digital system is proposed to therapists with the objectives to improve the performance of measurements, the reproducibility of evaluation, and the patient participation. It is developed along 4 axes: the choice of a 3D motor sensor, the development of software on a tablet for the assessment of fine motor skills, the proposal of a playful environment, and the integration of the tool into the current practices of the therapists. A friendly approach between therapist and patient is very often developed. It is therefore common for the therapist to try to make the assessment as pleasant as possible. In the case of young patients, therapists try to make the evaluation more relaxed, for instance, in the form of a game or of a story. Other important points are the adequacy of the game to the physical and cognitive capacities of the patient to perform a task, and the feedback given to the patient in case of partial accomplishment of the task, resulting in a low evaluation. For the realization of the animation, we propose a structural framework made up of 3 elements. It consists of a game scenario, the animation, which are transposition of the scenario in a visual and sound way, and the feedbacks, which constitute the information given to the patient. 5 recommendations serve as a guide for the development of the animations of the prototype items. The personalization of the animation means that the level of difficulty is adjustable by the therapist. The capture of movement is linked to the characteristics of the interaction interfaces. The feedbacks that should always be motivating and encouraging for the patients. The proposed animations must be compatible with the software and hardware technology used. And the game design must be in all respects to the item of the MFM. 2 scenarios have been edited. They were communicated individually to 5 physiotherapists, all certified to perform MFM exams. Once the results analyzed, the chosen scenario was reworked into a group of 3 expert physiotherapists in order to develop in the form of animation. 10 animations have been developed. For each item, an animation illustrates the way in which the task must be carried out. This is an example of an animation.
Tu continues et commences à t'éloigner de la rivière. Tu montes les derniers mètres de la colline. Tu es arrivé au sommet de la colline et tu dois désormais ficher l'antenne dans ce sol bien plus dur que le sable de la plage. Alors, accroupisse-toi puis relève-toi sans aide des bras. Une fois relevé, l'antenne vacille, réaccroupisse-toi pour mieux le fixer, puis relève-toi.
To conclude, an overview of the serious game design principle in the medical field has been done. We have defined principles, frameworks, and recommendations for the development of a serious game dedicated to an assessment scale. We have developed 10 animations and integrated them into the therapist's protocol. Here are the works to be done: development of other animations and validations, evaluation of the animation with more children. Thank you for your attention, and if you have any question.
Thank you, Guillaume. With a French intervention avec la vidéo en française. So, let us move swiftly to our third paper, and that is looking into, entitled One Size Doesn't Fit All, on the Adaptable Universal Design of Assistive Technologies. So quite nicely continuing in the stream. And it is presented by Leila Aflatoony, if I pronounce that correctly, with co-author. And Leila is from the Georgia Institute of Technology in the US, and shares with us on her biography a number of very, very interesting background elements I will select now. And one of the most important aspects is design-oriented HCI researcher, human computer interaction researcher, also with expertise in interaction design, design methods, and has worked with her group together, leading her group on a number of areas: mild cognitive impairment, dementia caregivers, dyslexia, and so on. Now, together with co-author, we are very interested in hearing what you have to say.
Hello, everyone. My name is Leila Aflatoony, and I'm a faculty at Georgia Tech. In this study, I collaborated with Siniša Kolarić, currently a researcher at Simon Fraser University, to investigate the current practices of assistive technology adaptation by occupational therapists. We propose adaptable universal design framework with the potential to address the shortcomings of universal design approaches to designing off-the-shelf assistive technologies. Assistive technologies are used to increase, maintain, or improve the functional capabilities of people living with impairments. Assistive technologies are categorized according to the complexity level of the technology used, materials, and operation. They can often either acquired commercially off the shelf or customized to fit the specific needs of individuals with disabilities. Despite the significant efforts to develop universal assistive technologies that are accessible and can be purchased off the shelf, there is an ongoing need for assistive technology adaptation and the iterative process of modifying so-called universal design assistive technologies to support individuals' unique needs and abilities. So it is common for assistive technology specialists to find the need for modifying off-the-shelf assistive technologies after they fail to support people with disabilities, needs, abilities, and specific activities. We conducted semi-structured interviews with 10 expert OTs to explore off-the-shelf assistive technology's shortcomings, reasons behind assistive technology adaptation, and types of assistive technologies that frequently require modification. We asked questions such as, how do you define whether an off-the-shelf assistive technology needs adaptation, and what factors do the adaptation depend upon? We audio recorded the interview sessions, transcribed the audio files, and used the affinity diagram technique to analyze the data. We summarize our findings in the following slides. The interview results revealed several reasons behind assistive technology adaptations, mainly due to body conditions of people with disabilities and costs associated with off-the-shelf assistive technologies. OTs brought up the uniqueness of patients' physical bodies and conditions as the main reason behind adaptations. Also, they brought up the functional and economic limitation of off-the-shelf assistive technologies as two reasons behind assistive technology adaptations. Most adaptations in the second theme have been made to support individuals' ability to hold items or use items with their hands. These adaptations take a few different forms, such as extending handles, adding materials to change grip size or shape, and creating holders for items. Additionally, OTs shared that individuals' ability to use household devices is crucial. Surprisingly enough, they also mentioned that high-tech assistive technologies require adaptation as well. It is relatively common to modify items such as controller switches and keyboards, as they described. Overall, while adaptation can be versatile, each increases easier access to items based on the physical needs and attributes of the person. Also, several OTs expressed the need to collaborate with people with disabilities in adaptation processes to achieve the best possible outcomes. Also, they described that involving the family of people with disabilities is crucial as well. Additionally, it is common for occupational therapists to engage people with disabilities beyond decision-making processes to help make and modify assistive technologies directly. Our findings illustrated the strong need for off-the-shelf assistive technology adaptation, and that despite the emphasis in the idealistic aim of universal design, accessible design, and inclusive design approaches to develop products or services that are usable by all people without the need for modification or specialized design, still many assistive technology specialists are actively involved in adjusting off-the-shelf assistive technologies to help their clients. Thus, we argue that the universal design approach would require considering additional or complementary principles in the framework. Some of these principles can be borrowed from the special design approaches. We propose Adaptable Universal Design Framework as a new approach to designing assistive technologies that allows modification. The framework should support extreme adjustability as a principle that takes into account individuals' evolving and unique needs due to the changes to bodily conditions and functions, and allows modification of previously designed products. The framework should facilitate stakeholders' collaboration in assistive technology development to guarantee effective outcome, and the product developed following the framework should be cost-effective and durable. There are several application areas in which adaptable universal design might be adopted by design practitioners, for example, in physical and digital artifacts, artificial intelligence, computer-aided design, and cloud-based platforms. This study explored the shortcomings of off-the-shelf assistive technologies that require post-purchase adaptation. Based on our finding, we identified the need for a new design approach, which we term adaptable universal design, with the potential to address the shortcomings of universal design approaches. Future work includes further development and refinement of the framework, guidelines, and associated principles. Thank you all for your attention. Please feel free to reach out to us at leila.aflatoony@gatech.edu and sinisha.kolarić@gmail.com. Thank you.
Thank you, Leila and co-author. Now, the next paper is on Cardinal maturity determination of technology development, a medical device development case study. And it is written by Soumya, Mishra, and co-author. And Soumya is a PhD student at the University of Toronto. His background is mechanical engineering, and he has a focus on multidisciplinary optimization. Now, I believe Soumya is not here in this session at the moment, nor is the co-author. If I look just once more through the people list, what I would suggest is that we still hear what the people have been working on. We play the video, and then we will incorporate it in discussion as we can. Fanika, if you help out, press start.
Hello, good afternoon. I'm Ranjan Mishra, presenting a paper on Cardinal maturity determination of technology development, medical device development case study, under the supervision of my professor Kamran Behdinan from the University of Toronto at the Advanced Research Laboratory for Multifunctional Lightweight Structures. For a brief background, in early April 2020, Professor Behdinan with a few of our stakeholders developed emergency ventilator system under a mutual agreement. Further along in May 2020, he was mandated by the Government of Canada under the NSERC Alliance grant to develop an assessment framework for the emergency use ventilators. This work is an extension of that work. For a very brief background on what are the problems, we identified there is a major gap between how a firm may benchmark the development of a medical device, especially under the state of emergency. This is why we have used emergency use ventilator as a case study. Our major goal was to identify a good benchmark and effectively track the progress and the maturity of technology during its development. We found that every TRL or technology readiness level which is used towards the assessment of these devices has to be tailored. And the second gap which we found is that TRL itself is a stage gate process. It's a very ordinal scale which cannot develop real-time tracking of a product throughout its various stage. And we propose a computational, a mathematical model to assess the maturity of a device at each stage of development. For methodology, we first go through various design requirements and the regulatory and the quality affairs which imply the development of these devices, and we create a very comprehensive list of requirements. This table states all the different product design requirements and the quality assurances which according to different standards of the world which undergo rigorous undertaking for developing a device. According to a very brief study on the TRL and its tailored fit towards medical development, we found DOD's TRL, which says what are the descriptions under each level of technology readiness a firm must undertake to progress its design and development. However, we found a few edits to be made to suit this TRL towards the emergency use ventilation. They are emboldened on the right side in the description. We selected 6 models of ventilators, 3 which were approved by the EUA and 3 which were open source and available for people to recreate. And we found that all of these 3 had a very similar level of maturity other than the ones which were already approved by the EUA. So the last 3 ventilators on this list which were highlighted were all in the stage of TRL 5 according to the description of the TRL description of DOD. They varied in their development time, and they also varied in the declaration of conformity, that is how many standards they did follow towards the development of a ventilator. Now, when a firm is developing these kind of ventilators, it's very important for them to track the progress of how much they have fulfilled the requirements of each standards to make sure that the device is safe. We try to integrate this into TRL sub-criteria level mapping, where we see that in TRL 5, we just use a sub-criteria known as quality to see what is the progress of the device and how it matures. And we compare this with the other 3 devices which were on the list. We consider the general standards, particular standards, and collateral standards as a sub-criteria for quality, and we see how many of these devices fulfill these requirements. Furthermore, we try to prioritize what is the importance of each standard in a precedence order using the best first method, the general standard over the particular standard over the collateral standard, and we assign them weights using the best first method. As you can see, the local weights of each sub-criteria is assigned so that we can clearly and distinctly mention which standard, which is the most important standard, it is always fulfilled, and so on. We then use the data for their maturity, that is the time of development over a span of 1 year, and see how much progress the technology has made within the dedicated time span. We use a time ratio, that is the time elapsed in development towards the total development time, and put it in the equation for maturity assessment, which we propose here. We apply this model towards the assessment of all the three ventilators, because they were all at TRL5, and it was very difficult for us to assess which one is more mature than the other without clearly identifying what is the involvement of quality. So this is a very this model is a very feasible model, a very open model, where sub-criteria can be changed at each level of technology, and at the end of it, you can always assess what is the maturity of each sub-criteria and the overall development of the product. So we see that all the models here are at TRL5. Based on the elapsed time of development and the time ratio, we find that 2 of these share a similar time ratio, but the sub-criteria, when being assessed, it gives us a very clear distinction between the last 2 candidates. Using this model, we get a very clear overview of which product is more mature. The TRL usually does not discriminate or distinctize these products, because they are all at TRL5 according to what the TRL states, and it's very subjective to each category of product. This model enables one to visualize what is the maturity of the different products at the same readiness level, and how well a firm can easily acquire a more ready product for their system. This model can be further analyzed based on different sub-criteria individually, that is the time maturity and the quality maturity, as illustrated in this table here. So in conclusion, we scrutinize the ordinality of TRL, and we propose a weighted TRL approach, which gives us a quantified method to measure the maturity of a product based on different sub-criteria. We see that it is very much important, a very viable mathematical model which is accurate towards the determination of the maturity we proposed, because most of the previous models had a lot of mathematical inconsistencies in the formulation. And also we realized that each industry, depending on the product itself, should have a tailored description of their product for the determination of maturity. And it's not very generic that ordinal TRL fits all. This work has been a part of a series of articles which were published earlier, and this is the final work towards concluding this project. This is something which we hope everybody utilizes in the future to assess technology before the acquisition. Thank you very much.
Okay, thank you, Soumya and co-author. Now we are geographically coming full circle in some ways. So we started out with the University of Malta, flying over to France, thereafter to North America, both the US and Canada, and now back to Malta in a collaboration with a German university as well. And if I look at the people being here in this session, contributing in the discussion later, it's a truly global representation, and that's fantastic. So very, very nice. I'm looking forward to the discussion. Now, before we do that, I see also some people using that chat already for questions. Wonderful. Keep it coming. This will give us a good base for later. Now, our final paper in this session is entitled Towards a Product Service System Framework for Lower Limb Prosthetic Devices, and is presented by Nicholas and co-authors. The floor is yours.
Towards a Product Service System Framework for Lower Limb Prosthetic Devices. Research motivation. Amputations have unfortunately become common in today's society. These amputations can be caused by a number of things, ranging from infections and diseases to accidents and injuries, and the more recent event, wars. Prosthesis Development Information Flow. Here we have the current life cycle of a prosthetic device, which has been broken down into 3 sections. The first section is where the amputee and the prosthetist interact such that the design requirements can be determined. after which the prosthetist designs a prosthesis and orders the standard subsystem parts. The second section is where the manufacturer comes into play. This is where they produce and assemble the standard subsystem parts before dispatching them to the prosthetist. The third section is where the prosthesis starts being made, starting from the socket to the prosthetic device. I would like to emphasize the difference between the information flow in the blue arrows and the material flow in the red arrows. Main observations. Amputee problems. Cost of the prosthesis is too high, forcing patients to go for less expensive low-end devices. The time that the amputee has to wait before receiving the fully assembled prosthesis. Prosthetic devices tend not to appropriately cater for the emotional needs of the amputee. The lower limb prosthesis would have to be replaced several times throughout the amputee's lifetime. Prosthetist problems. Lack of customization for above-knee system parts. Socket casting and manufacturing is a long and labor-intensive process. Long waiting time for standard subsystem parts to be delivered. Manufacturer problems. They are unable to develop high-quality yet low-cost lower limb prosthetic devices, resulting in less sales. Prosthetic devices are not accepted in all cultures, reducing the reach of their prosthetic devices. Designers do not interact with specific amputees, thus they are not able to fully understand their specific needs. Prosthetic devices are not designed for multi-X, but tend to focus on functionality, thus serviceability and disposability are not catered for. Amputee survey analysis. Detailed amputee questionnaire was then devised and the appropriate stakeholders were approached. The questionnaire enabled the team to obtain the relevant information through the amputee's opinion and experience. From the survey, we were able to obtain various results. While we cannot go through all the results obtained, certain key points can be shown. When the amputees were asked to choose 3 key requirements from a list, the most relevant answers were socket comfort, advanced improved mobility, ability of upgrading with a new feature. Additionally, when asked about smart features, the older generation felt that they were not necessary. However, the younger generation thought that this was a good idea, as they liked features such as step counter and calorie counters. Key specifications from amputee analysis. From the amputee analysis, the team was able to ascertain the key requirements. These requirements are the weight of the prosthesis, the alignment of the prosthesis, the time it takes for the amputee to bond with the prosthesis, and socket comfort. The ProList framework. Recall the prosthesis development information flow. From this, we can determine that there's a design phase where the prosthesis is designed and a realization phase where the prosthesis is made. Here we can see 2 user-product interactions during different life phases, where the green flow represents a traditional product, in this case a photocopier machine, that makes use of a product service system, and the blue flow that represents traditional healthcare service, by which an amputee receives their prosthesis. It is important to note that the amputee is not involved in all the different life phases. Here we have the ProList framework. While there's a lot of information to digest, I would initially like you to take note that there are 5 life phases. The amputee is provided with a co-design service, as he will work closely with the prosthetist and the technical designer to arrive at a solution satisfying their requirements, yet able to be produced from a range of standard parts. This service consists of CDS1, which is a user-centered design and planning approach, as well as CDS2, which consists of a liaison between the amputee's needs and the standard part suppliers. The prosthetist and the technical designer can now design for multi-X and cater for the amputee's emotional as well as their needs. Realization phase. During this phase, the amputee is provided with a customized prosthesis development and fitting service, which is suited towards his physical and emotional needs. The prosthetist and his technical service team will develop the custom parts to fit the amputee's residual limb and assemble this together with other standard parts required from manufacturers as dictated by CRS1. The amputee is also serviced with the fitting refinements to the overall solution to ensure a perfect fit. The use phase. In this phase, the amputee makes use of customized prosthesis that was developed in the realization phase. This prosthesis will enable the amputee to regain their mobility and allow the amputee to perform daily tasks, in addition to catering to their emotional needs. This service consists of CUS1, where the data collected from the prosthetic device, while being used, is monitored and processed such that further improvements in the next iteration of the prosthesis can be made. The servicing phase. During this phase, the prosthesis is serviced and maintained, keeping its proper level of quality and performance. The services provided to the amputee are CS1, which consists of maintenance and fixing of the prosthesis. CSS2, where the device is being serviced, and CSS3, where worn out or damaged parts are replaced. The servicing could also include adjustments to the existing device to improve its performance. The disposal phase. During this phase, the amputee is supported through an environmentally friendly and safe disposal service of the prosthesis, besides being provided with a replacement prosthesis. As part of the service, CDS1, discarded prosthesis elements are separated into unusable parts, which are disposed of, and parts that can be repurposed and reused. Here we have the full progress framework. What I would like you to note is that the amputee is now involved in all of the phases. Conclusions. Progress evaluation, strengths, user-centered design, collection of feedback, involvement of all key stakeholders, extension of prosthesis life. Weaknesses, capital expenses, complexity of framework, design of prosthesis may take longer. The progress framework has been prescribed to cater for the involvement of the amputee in the different life phases, to ensure that the lower limb prosthesis is customized for the amputee's needs that change and evolve over the amputee's life. The amputee will be able to provide valuable insight in terms of both current and perceivable functional needs, as well as the emotions that the prosthetic device elicits. To ensure valuable feedback provided by the amputees is captured and appropriately used by the designers, each and every servicing team in the different life phases includes a prosthesis designer. Future work. The progress framework shall continue to undergo further evaluation and shall be tested in vivo with key stakeholders.
Yes, thank you, Nicholas and co-authors. And to complete, Nicholas is now working as a research support officer at the University of Malta and has a background in biomedical engineering from Strathclyde and electrical and electronic engineering from the University of Malta. And I shall also add, Leila is an assistant professor. So now we've come through all current positions and backgrounds. Now, let us open up the discussion. Could I invite people to share their audio and video, or video in the first place? We have enough spaces for you to come up on screen should you wish to do so. And I also see already some questions in the chat. So let us begin with the questions in the chat and then take it as it comes. Now, I can see questions to Matthew, Guillaume, and Leila. Now, let's take it from the top. And Alexander, if you care to share your video, you could then perhaps clarify a question should it not be sufficiently answered. So Matthew, if you start out responding to Alex.
Should I?
Hello.
Hello. Okay, you got a question, right?
Yes. So to answer the first part of your question, it's how were the interviews participants selected? I used most convenient sampling, considering that it was quite like I had to consider that they had experience in medical device design, additive manufacturing as well. They were familiar with user experience, so convenient sampling was used. And with regards to the second part of the question, how did you go from the interview data to the proposed framework? So initially, I asked the participants their experience with and design process they used to design medical devices. We were considering medical devices at the beginning, or other products that are used in rehabilitation, such as maybe assistive devices, prosthesis, or orthesis. And once we went through that, I presented a simple framework and then we discussed where design for additive manufacturing should be placed with regards to the whole framework. I also supported a bit the framework with literature, and then I presented it as it is. Obviously, this is still the preliminary framework, so I still need to validate it and see if it works. I don't know if I've answered your question, Alexander.
Yeah. When you said convenience sample, do you mean is that from the same organization or is it just
No, different
People that
organizations like
people that you know, right, who are designers, or
no, as in I don't know these designers, as in, but I searched through them to product design bureaus and
okay.
went on from there.
This links actually quite nicely to the question by Guillaume for Matthew. Maybe we could take that. If you were to rephrase, or Matthew, if you read, it's digging a little deeper into the profiles of the interviewees.
Yes, if there are only occupational therapists. So for the study, only engineering designers were considered, as in they were interviewed only. But we conducted a previous study before this with occupational therapists and other expertise, and as well the parents of children that undergo therapy to get their perspective on designing smart wearables for pediatric habilitation.
Okay, I can complete my question. Yeah.
Yes, go ahead.
Because I think I'm doing almost the same work with one master students currently. I want to know how can the occupational therapists use additive manufacturing to increase the quality of different criteria of the product. And the interviewees you meet during your research, did you know if they already have some experience about Fab Lab or other technologies?
In our case, as in I'm not considering that the occupational therapist will be using the CAD or additive manufacturing per se, only the designers. So
Okay.
not the occupational therapist directly.
So you don't have any ideas or motivation to add this practice for occupational therapists in their process?
Yes. To be honest, I think I found some like previous study with regards to medical professionals using CAD modeling to actually to print the devices themselves for more simpler devices such as orthesis. But some of them commented that it would be a bit complex for them to carry out. And
Yes, I agree with you. Yeah.
Process of implementing additive manufacturing process parameters, etc.
Now, mainly we observe that it's engineers who helps and participate to this process with occupational therapists. The idea is to imagine that occupational therapists can be independent with the use of this kind of low-tech technologies, and we try to compare the both situation with an engineer and without an engineer to help in the design process. This is an interesting question. Advantage and other consequences. Thank you, Matthew. Very good work.
Thank you for your question.
And that's also nicely linking your screen neighbor, Leila, has worked with occupational therapists a lot. So perhaps there is also some experience to share.
Sure. On this question, or on the question that I got related to my study?
I was thinking on the occupational therapist, but it can also be offline. Guillaume and Matthew and Leila have a discussion on the interaction between designers and occupational therapists.
Sure.
Let's maybe go through the questions first. And so, yes, there is one for you, Leila. So, Alex,
yes,
if you
that's
care
a good question. I think I'm ready to provide answer. Thanks for asking that question. So our study was focused on what assistive technologies in general need adaptation and modification. And we found that basically ADLs, assistive technologies for aided daily living, such as something to help them to, hold their toothbrush or spoon, etc. Those are basic needs for people with disability to, with independent living, to support them in independent living. So that was the most common in terms of required modification. So we did not collect necessarily, there was no question on that, but there were some themes and evidences that showed there are some assistive technologies that, of course, all these off-the-shelf universal design based assistive technologies are developed with the hope that they don't need any modification. And if they are lucky enough, I would say also occupational therapists, they're not usually looking forward to do modification. So if an assistive technology helped them, the way they purchase it off the shelf can help the patient as it is, perfect. And that's the case. There are many that still work. I would say, so in general, when generally speaking, when assistive technologies develop with adjustability in mind, for example, if they develop a handle for a spoon and they consider left-handed patient and right-handed patient, then that does not most probably require adaptation. Or so the more I would say they're adjustable, the less there is a need for adaptation. But there's no really, I could not, since this was outside this study and maybe future study, I cannot refer to specific assistive technologies that does not require adaptation, but I would say there are many that still works as it is. And in general, so the one that also require, so the one that has warranty, they're more expensive, such as wheelchair. Usually occupational therapists don't like to touch them or change them, because then if there is any problem, they can return it. And so even though, there might be a need for adaptation, they don't touch it. I don't know if that's a little bit outside of your question, but I tried to just provide different perspective. Yeah, thank you.
Okay.
For the
I thought I was just very curious in terms of all the different possible assistive technologies out there, and thinking whether it would be quite interesting to see which are the ones that they use without adaptation and which are the ones that they use, to see what is it that makes it different in terms of what they don't adapt and what they do adapt. But as I say, it may not be the focus of your study.
Yeah, so the one that do adapt really is the one that, because people with disability have different types of, different level of, they're sitting in different spectrum. There's this spectrum of disability and ability, and depending on where the level of the ability, let's say, and then there is a need for adaptation. And for example, when you refer to their hands, depending on their hand dexterity, how they can grab some items, how strong their muscles are, they may need to, for example, create a handle, a spoon holder handle, something that, like that, with like thicker handle or thinner handle, and different forms, and softer, harder, depending on what, again, the requirements, the need of patient.
Thank you.
Yeah, and I can see also here in the answer links to Nicholas, but maybe we get, in terms of comfort and so on, but we get to that in a second. I see Philippe linking to Guillaume's paper and co-author, and so there it's a form of adaptation as well. If you new design, you have to adapt to regulations, right? So I guess, Philippe, if you share your question.
Yes, so my question regards the regulation when it comes to a serious game from a medical point of view. Because if you are collecting data from patients through a game or through another means, that is considered also as a medical device. So in your approach, to what extent did you consider this aspect of certification?
Yeah. Okay, so at this time, we don't have any official certification for these serious games. We have to differentiate approaches when you design serious game for diagnosis or for rehabilitation. In fact, okay, here we have to develop. We propose the development of a sum of different of 32 games, little games. The objective is to is to propose a more motivating environment, okay? But it is always the therapist who will directly evaluate the performance of the children in front of the screen, for example, or doing the exercise on the tablet. We don't use the measurements for realizing a database of data, okay, for analysis of the data after. The first objective is to make the evaluation more motivating, okay, because they know that they will enter, that the children will enter in the room to evaluate the disability, okay, they don't want to do that. So the idea is that, and I want to add another thing, is that we worked with the team in Lyon, in France, who created the MFM assessment 25 years ago. So they know exactly the exigence and the requirements to practice each items, okay, of the MFM. So the manual, the occupational therapist experts currently used to do this MFM. So this manual is officially validated by occupational therapist societies in the world. Okay, so the objective of the serious game is to follow exactly each step of each items of the MFM. Okay, so
so the game is a manifestation of the protocol.
Exactly, it's a copy. It's a copy of the protocol, but in numerical environment. Okay, but we have to be careful about the exact information which are given to the patient, because there is a protocol very strict. In fact, okay, we cannot change this official protocol. Okay.
Yes. Okay.
Mm-hmm.
Thank you.
Maybe we can use this question or connect to Nicholas in that way as well. In your framework, are you considering any regulatory constraints? Or
as of yet, sorry, continue.
Yeah, no, go ahead. Question mark?
As of yet, we haven't tested the framework, so we're not sure about the regulations. Mm-hmm. But we will be testing it shortly with patients and therapists alike. And then we will fine-tune it properly.
Yeah. Okay. Yes. So are there further questions at this stage to the speakers or amongst the speakers? I have one that I would like to share with all of you and invite the speakers to come with their view. So given that this session is called Healthcare Case Studies, so these cases presumably have target audiences and presumably, hopefully, have impact. Now, could you share one sentence that you wish people to remember about the impact of your case study?
I can begin. So one sentence I can propose. So increase the motivation of patient for motor evaluation.
Mm-hmm.
It's okay?
Yeah.
It corresponds to your demand?
Yes.
Yes.
And target, yeah. Yes, okay, we'll go for the next afterwards. All right, increase the motivation for...
Yeah.
Yeah. Who would like to go next? What is their impact?
Mm-hmm. So I think there's a need to increase the capacity of assistive technology design, make it more adjustable to support occupational therapists, helping individual with disabilities better. It's a long sentence.
Yeah, exactly.
Okay, Yeah, so it's enabling technology. Yeah.
My sentence would be that we make use more of additive manufacturing to reach sort of the full potential of different users by, as Leila's mentioned, that one size sort of does not fit all, and that devices need to be more specific for the user as we.
Okay. Yeah.
I would say essentially to increase awareness of the needs of the amputees and relative stakeholders, because they're not all being considered.
Okay, so design's role is perhaps using technology to enable user behavior, or approaches to enable users to share their needs in order to design for their needs. Okay, now another, I'm looking at the chat just once more. Okay, I think we have those questions. Another, and that's also a theme that has gone through the health sessions that I've participated in early in the day also, and that is the designing with health practitioners, clinical scientists, other stakeholders. Now, could we perhaps share some experience here also from your case studies, in what way you have interacted with domain specialists, be it, we've heard now about neurological diseases, motor diseases, amputees, and a number of other areas. Could you share there also, so your main design partner, so to speak?
So maybe I can go. So the main design partners for my case, considering that we are considering pediatric habilitation devices, so devices for children, apart from the primary users being the children, we would consider the parents, being that they are the people sort of most close to the child, and the occupational therapist as well, due to their experience with pediatric habilitation.
Yeah, I can complete, or I can say the same thing. I work a lot with occupational therapists because we work with mainly with motor disabilities children, and because we are working with mechanical interfaces to practice musical instruments. So I work also with a professional from the Conservatory of Music, and when we design a product, an interface, to be able to propose a children to play the music, we have to be careful about the quality of the music. So we have to design an interface which will produce a quality of sound, and we have to take into account the quality of the final results of manipulating the product, and also the ability and the disability of the patient. Okay, so it's a concrete example in parallel of this presentation today.
Yeah, but also very interesting. It's also with domain experts from another domain. Leila or Nicholas, perhaps?
Sure, I go next. So similar to my colleagues, so I've worked a lot with occupational therapists and people with disability, since we do all co-design, of course. For slightly different reason, I work with occupational therapists. We all know that they're working, helping people with disability in different ways, and I'm more excited and interested in their DIY aspect of design. So they, even though they're not in design field, they try to always help their patient in any way, even like by tweaking and adjusting current assistive technologies that to me, as a person coming from design background, always I'm always interested and amazed by what they can do and how far they can go to try to help their their clients by going beyond their expertise. And that's why I see that occupational therapists and designers co-design is a fantastic way to collaborate, work with occupational therapists, because they're doing design anyways. And then my research question in general is how to support them as designers and some of my other current studies to be a designer. And so how we can help occupational therapists with design to help their clients better, since they're already doing it.
Yeah, and perhaps Nicholas.
Yes. So I've been working closely with other researchers as well as the amputees themselves, both local and foreign. And I have also talked to the relative medical personnel as well. So far, just local, but we're getting in touch with foreign as well. So it's, yes, you're going to say something?
Yeah, I think it's really interesting what you all shared, and that we're designing with and working with various stakeholders. And now it's obviously the question, in what way are we developing designing, or are we using designing to inform other domains, or is it both? And with that comes then the question, obviously, how do we share our research? And again, I look at case studies and impact, and I wonder whether the manuscripts that we write, they are for us as scholars, and if we have other ways of sharing our work to motivate, as you mentioned. So maybe there's a video that you use that demonstrates, and it's also Alex's question was which assistive technology might work. So as a last one before, just a very quick, and then we'll wrap up. What other ways will you use to demonstrate or share your results with the partners you've just mentioned you're designing with? Because again, we have a case study, and so I am thinking impact in practice. That's how I'm interpreting case study. How are you sharing your results for impact with the people?
Yes, we are. For me, if I go back to my experience with a musical professional, it's easy to answer because we did some representation each month, I think, in amphitheater with a lot of children playing the music and with a lot of auditorium of people listening to the music. So it is an idea to share and to explain in each between each part of the concert. We explain how students participate to the design of this interface with disabled children. It's very interesting for the people who are listening to the music to know how the interface has been designed with students from the university and the children and occupational therapists also.
Yeah. Yeah. Okay. Let's have you answer first, and then I share my thoughts. Very inspiring. Nicholas, perhaps. What other ways might you use to share?
So at the moment, we're using social media, which has quite a large outreach, but we're also using in-person interviews as well. So we're trying to do a mix of both. While we are able to reach more people with social media, they are less personal. And I therefore prefer an in-person approach. And we'll eventually be able to show them things in practice as well.
Yep. Matthew? Or?
Yeah, I think the same. We try to reach out to occupational therapists through social media mainly and share our work and before and after. I mean, the idea, but also we usually send flyer, and that way we connect because they're interested when we follow up with them, etc. This is more about recruitment as well. But for this study, since this is very theoretical, right? It's about framework and how we can like improve universal design, we just share the result usually with them, the paper itself. But there are more applied research that I've done in the past that we usually try to take it to the next level and do workshop with them and do co-design and just invite them to design with them.
Yeah. Okay. Matthew, a crisp one.
Similar as they mentioned, mostly as in through social media and maybe other platforms like newspapers and magazines to get sort of your message. And as well, maybe workshops would be, I think, ideal to target the main audience. Sort of.
Yeah, that's really interesting and inspirational, because I wonder whether we have the opportunity in the design community and perhaps even the design society to use multiple ways of sharing this impact we have, videos and so on, all that you mentioned. And there is also in the medical field, if you Google hearing for the first time, for example, children or other users having cochlear implants, when that's put in and they hear for the first time, the reaction, and that just sticks with you. And I think we have as designers such a huge chance to make an impact through tangible demonstrations. And I saw it in all your healthcare cases, which can be developed further in that realm as well, and thereby help the design discipline show what we can do. Now, okay, so it remains for me to thank you all, the presenters, the people sharing or participating in this discussion session, the organizers of the conference, and especially also Fanika for her support here to make everything so smooth on this video platform in this session. So hopefully our conversation continues. Let us look up each other's papers, and when we have the possibility to travel again in person to the next conference or a workshop, let us connect.
Join the health system design SIG as well.
Indeed, exactly. I said it at the outset. I can close with that. That's right. You're very, very welcome to share your expertise and develop the health systems design, co-develop it together with people already there and beyond. Yes, so thank you all. And I see in the chat, Fanika has shared that the social gathering is starting in 2 minutes, if I did the time conversion right. So enjoy the remainder of the conference. Hope to see you again. Thank you for the session today and keep up the good work.
Bye.
Goodbye for now.
Thank you.
Bye-bye. Bye-bye.
Bye-bye.
Bye-bye.